Assalamualaikum. My name is Anissa Tasha binti Muhammad Nizam as a group leader.
My name is Nur Fatiha Nadira binti Nur Azlan.
Hi, Assalamualaikum. My name is Nur Izzati Alia binti Fazli. Here is our presentation outline by referring to Table of Contents. Chapter 1 Introduction, Chapter 2 Background Theory and Literature Review, Chapter 3 Methodology, Chapter 4 Implementation, Chapter 5 Result and Discussion, Chapter 6 Conclusion, and lastly Chapter 7 Recommendation. Firstly, for our abstract, the queuing theory model is the quantitative observation of congestion and disruptions while waiting in line. In general, a queue forms in a production system when the number of customers, which are human beings or physical entities, requiring service waiting time exceeds the number of facilities available to serve them. This study aims to compare the behaviors of a queuing system and an order counter using the fuzzy queuing model, which are the Dong, Shah and Wong DSW algorithm and the left-right LR method. One of the approximate methods that employs intervals at various alpha cuts is the DSW algorithm. In a standard interval analysis, it was a complete alpha cuts intervals, while in the LR method, the priority discipline fuzzy queuing model is being examined and summarized in two kinds of situations, which are no priority discipline and preemption priority. Based on our study, the problem often occurs when the deficient customer's time service during service delivery has an impact on customer flow and the time service provided to the next customer. The customer's time service during receiving the services will be affected, the customer flow, and the time service for the next customer. Data variables have been gathered, including service time and server queue arrival time. Results indicate that the completed performance measures of the fuzzy queuing model in the LR method are within the range of the performance measures of the fuzzy queuing model in the DSW algorithm. Thus, the DSW algorithm is the most effective way to minimize the waiting time at the service counter and fuzzy queuing model in the system. For further study, a different researcher might use a different fuzzy queuing model in the system to address the same issues such as the fuzzy inference system FIS and the ranking function method RFS.
Chapter 1 Introduction. The food and beverage F&B expert work relentlessly to improve the customer experience via their service. Customer flow is an important flow in any business, that the number or pattern of consumer entering or exiting a company. However, to optimize customer flow, a company should not have a long queue, which means it has too few staff and it's not good for the customer experience, or no queue, which means too many staff and it's clearly inefficient. The DSW algorithm greatly simplifies manipulation of the extension principle for continuous valued fuzzy variable. For example, such as a fuzzy number defined on the real line. The priority discipline fuzzy queuing model is examined and summarized in two situations, which are no priority discipline and preemption priority. Problem statement. First, deficient customer flow because of a different queuing theory method has been applied in the system, and choices can be made for the best method that can be used to improvise the customer flow. For the objective, to determine the performance measure between the fuzzy queuing model by using the DSW algorithm method and the left-right method. Second, to compare the methods between both methods, which are the most effective to minimize the waiting time at the service counter and optimize the customer flow. Significance of study. The benefits of the study can be viewed along with three stands, which are research, practice, and policy. The location that we agree on is Pizza Hut in Surat Bandar 9. The study can find out the estimate arrival and service time for them to complete their customer order for their pizza. This action is to choose which one is the most effective in minimizing the waiting time at the service counter while optimizing the customer flow. Scope and limitation of study. This study is focusing on customer flow by using the DSW algorithm and the left-right method. The project goal is to maximize service time in order to reduce customer wait times at the Pizza Hut service counter. All of this data will be collected manually every Sunday for a month starting in November 2021. We collected the data starting at 12 p.m. and ending at 4 p.m.
Background theory. Queuing theory model is to construct a model simple enough so that it yields to mathematical analysis that contains sufficient detail so that its performance measure reflect the behavior of the real system by Hilinka in 2018. Shanmunga Sundram and Tamisalvi in 2018 also state that the fuzzy queuing theory seems to be more practical to be implemented in a real queuing situation rather than a queuing theory model. Besides, fuzzy queuing theory also the use of fuzzy mathematics in possibility concept and fuzzy Markov chains for the analysis of queuing system that can be dated back to at least 2 decades ago. Type queuing theory model. Based on Streethall in 2001, a waiting line will be formed whenever the current demand exceeds the current capacity to provide the services. Helenka in 2018 discovered that the order arrival followed a Poisson process with one of the Poisson process properties where time between arrival are exponentially distributed. The author acknowledged that the queuing theory also can be used to forecast a significant variable like the average customer service, average queuing time, average of ordering Pizza Hut, and also average of pizza can be done. Based on Kavita and Altman in 2009 have discovered that the number of queues served by a single server in a periodic manner consists of the pooling system. Koka et al. In 2017 proved that the single queue multi-server model is better than multi-queue multi-server model and generalized the mathematical relation of the performance measures of both queuing models. Many researchers like Lee.R.J. and Lee.E.S. in 1989 discussing comparison of fuzzy number. Zimmerman.H.J. introduced fuzzy linear programming and its application. Shanmugam Sundaram.S. and Venkatesh.P. in 2015 presented a multi-server fuzzy queuing model using the DSW algorithm. Xiao and Shang demonstrate that a single line is preferable to multiple lines. Multi-server queue has two or more service facilities in parallel, providing identical service. More than one station can service all the customers in the queue. The arrival time and the service time follow Poisson and exponential distribution. For continuous value fuzzy variable, such as fuzzy number defined on the real line, the DSW algorithm considerably simplifies manipulation of the extension principle.
Chapter 3 Methodology. For the main methodology, Step 1. Studying the concept of fuzzy queuing model by using the DSW algorithm and the LR method. We need to study the background of both methods and devise an equation to answer the issue. Step 2. Gather the data. In this step, we are collecting the data at Pizza Hut Rumah Prima and the data has been collected from the system for a month. Step 3. Analyze the data. The data collected will be analyzed by using two different methods to measure queuing performance. Step 4. Result and discussion. The research study's conclusion will be presented in the form of figure, graphic, and table based on the result attained. And then we compare and contrast the result. So, for the conclusion and recommendation, the steps show if the objective of the study were achieved or not, and there is a recommendation suggested for the best method to measure queuing performance. Next is the flowchart for calculating the performance measure. Start with phase 1, data capture and analyze input parameter. After collecting the data, it was analyzed to determine the average arrival rate, service rate, and number of services, followed by computing queuing performance. In phase 2, section will be divided into 3 subsections, which are the fuzzy arrival rate and service rate, and evaluate it using both methods. Last, in phase 3, we compare the result based on the performance measures of the queuing theory model between the DSW algorithm and the LR method. Therefore, we will choose the most suitable method that shows great performance. Chapter 4 Implementation. The data obtained is analyzed to get the input parameters, which are the arrival rate and service rate. These parameters are used to measure the multi-server performance using the fuzzy queuing theory model.
DSW algorithm calculation step. The first step is selecting the alpha K value range from 0 to 1. Step 2. From the calculation of input parameter calculated in section 4.1, the value obtained for arrival rate lambda equal to 4 customer per hour and service rate mu equal to 6 customer per hour per server. Figure 8 shows the triangular fuzzy number for arrival rate. Minimum value for arrival rate is 1 customer per hour and maximum value is 6 customer per hour. By using MATLAB software, we can obtain the graph in figure 8. Therefore, the range of use for arrival rate is lambda equal to 1, 4, 6. Equation 39 shows the triangular fuzzy number for arrival rate. By using equation 40 and 41, equation 42 will obtain to get equation 43. Figure 39 show the triangular fuzzy number for service rate. Minimum value for the service rate is 4 customer per hour and maximum value is 9 customer per hour. By using MATLAB software, we can obtain graph in figure 9. Therefore, the range used for service rate is mu equal to 469. Equation 44 shows the triangular fuzzy number for arrival rate. By using equation 45 and 46, equation 47 will obtain to get equation 48. From equation 39, x equal to 3 alpha plus 1 and 6 minus 2 alpha. And equation 44, y equal to 2 alpha plus 4 and 9 minus 3 alpha. We can get the equation for x and y. By using the interval arithmetic analysis for division in equation 5, x substitute alpha equal to 0 in equation 39 and 44. Arithmetic calculation step. By substituting the value of average arrival rate lambda equal to 4 and the value of service rate mu equal to 6, we get the following membership. From the membership, we get the value of D and C of lambda, which is 1 and 4 respectively, and we also manage to calculate the value of D and F of mu, which is 4 and 9 respectively. Hence, in fuzzy we wrote it as lambda equal to 146 and mu equal to 469. To get the left-right representation of lambda and mu, substitute the value generated from the membership in formula 37 and 38. Therefore, we will get lambda equal to 432 and mu equal to 623.
Next, for our result and discussion. Firstly, we do the performance measures by using the DSW algorithm. Starting from this chapter, it's been broken down into one part, namely performance measures of the fuzzy queuing model using the DSW algorithm. The information was gathered from the Pizza Hut restaurant counter in Seremban, Prima, Negeri Sembilan. As determined, this data were manually gathered for a month. In our report, we have shown a table using the DSW algorithm for their performance measures. Based on the table 3 shown in the report, there are 11 listings of alpha cut which are 0 until 1. All of these values are being used for a measurement of alpha cut for arrival rate lambda and service rate mu by using Microsoft Excel. Hence, in table 3 shows the performance measure of the DSW algorithm. There are LQ, LS, WQ and WS. The range at alpha 0 represents the performance measurement, whereas the range at alpha 1 is likely to represent the performance of measurement mentioned by Srinivasan 2014. Furthermore, alpha 0 is the support of the performance measures that it might appear, and alpha 1 is the core of the performance measures. This means that the performance measures falls within range of alpha 0 until alpha 1 and it never falls outside the range. Next, for the performance measures by using the left-right method. The performance measures for LS, LQ, WS and WQ are calculated manually as shown in the table 4 in the report. If alpha 0, there is a possibility for the performance measures to appear. However, if alpha 1, then the performance surely appears. Thus, alpha 1 is the core for the performance measures in this study, while at alpha 0 is the support for the performance measures to appear. For this study, the average mean of the performance measures lies in the range of alpha 1 to alpha 0. Therefore, this will indicate that it never falls outside of the range of alpha 0. Hence, Microsoft Excel is being used to compute the graph of the performance measures, which is LS, LQ, WS and WQ. The last part for chapter 5, performance measures for the fuzzy queuing theory between the DSW algorithm and the left-right method. The first objective of this study is to determine the performance measures that are LQ, LS, WQ and WS for the fuzzy queuing model by using the DSW algorithm and the left-right method that applied at Pizza Hut in Seremban, Prima, Negeri Sembilan. Based on the discussion in section 5.1 and 5.2, the performance measures for the fuzzy queuing model between the DSW algorithm and the left-right method provide the range values. The DSW algorithm's output provides more comprehensive and effective knowledge, which is helpful when describing queuing system methods between the DSW algorithm and the LR method to determine which method is the most effective to minimize the waiting time at the service counter and optimize customer flow. Based on the table 5 shown in the report, the performance for the fuzzy queuing model by using the DSW algorithm is not consistent with the LR method. The result shows that LQ for the DSW algorithm is approximately less than 1 customer waiting for an hour in the queue, while LS for the DSW algorithm there is less than 1 customer queuing in the system for an hour. For the LR method, there is more than 1 customer waiting in the queue for less than 1 minute, but the LR method is more than 1 minute for the customer waiting in the queue. Significantly, the DSW algorithm WS is a customer waiting in the system. It takes around 15 minutes to an hour. All the values for the fuzzy queuing model by using the DSW algorithm lie in the fuzzy queuing model by using the LR method range value of alpha 1. This demonstrates that the DSW algorithm is the most effective way to minimize the waiting time at the service counter and optimize customer flow. Therefore, the last objective is achieved as well. For our conclusions in this study, with all the calculation done in Chapter 4, there are few reasons that we need to believe that at some point, people, especially customers, for any fast food restaurant, need to wait too long to get their food. However, the result shows that the performance of measures LQ, LS, WQ, and WS for the fuzzy queuing model by using the DSW algorithm and the left-right method were computed and compared. According to the findings, the fuzzy queuing model using the DSW algorithm is significantly more effective and efficient to assess the performance of multiple servers in a queuing system because the fuzzy set theory is more easily adaptable than the other theories mentioned by Simeori 2011. As a result of the application information being much simpler to comprehend and interpret, it is also possible to draw the conclusion from this study that the fuzzy queuing theory using the DSW algorithm is one of the alternate methods we have to determine the best performance measures. Consequently, the DSW algorithm is a different method of evaluating the efficiency of a multi-server in a queuing system. Next, for our recommendations. For further study in the future, a different researcher might use a different fuzzy queuing model in the system to address the same issue. According to Oslam Item 2008, the fuzzy model can be computerized and user-friendly software for managers can be designed to help organizations have a better queuing system with software that is much simpler to use. It is suggested, for instance, to extend the fuzzy queuing model by using fuzzy inference system (FIS). Due to the complexity of fuzzy, a thorough understanding of fuzzy is required to compute the performance measures using the fuzzy queuing method and to properly interpret the results. Lastly, in fuzzy queuing, we also can use the ranking function method in solving the same problem that exists in queuing system.